Okay, so this is composition of a hydrate, and I have just taken the data from the lab. First of all, I know the hydrate is a copper 2 sulfate. I just don't know how many water molecules there would be. So that's our job to figure that out. Got this data from the lab. So now it's time to figure out the mass, the rest of this data table, and then we can get going. So to figure out the mass of the hydrate, we would need to subtract this right here, which has crucible lid and hydrate, and get rid of that. So 24.11 minus 12.73. So let's do that. 24.11 minus 12.73. So this is 11.38 grams of the hydrate. Oops, I guess I didn't want to do that. Go back. Okay. The anhydrate would be the 20.11 minus the 12.73. So this is the 7.3. Oh no. Whoops. I was drawing with that. 7.38. This is, and I'll show you here. Okay, so this has water. That's water. This has no water. So to figure out what the water was, this is like with water, we'll subtract these. So 11.38 minus 7.38 gives me 4, maintain your sig figs, 4 grams. Okay, so 4 grams of water was driven off. Whoops. Okay, show all work and labels, etc. Calculate the number of moles of anhydrate. Show all work. So to go from grams to moles, we are going to divide by GFM. So we have moles of anhydrate, which is 7.38 grams. Now the anhydrate is this part. Okay. So to find the GFM of that, we need copper, sulfur, and oxygen. So copper is 64, and there's one of them. Sulfur is 32, and there's one of them. Oxygen is 16, and there's 4 of them, so that's 64. So 64 plus 32 plus 64 is 160 grams per mole. So then let's do that. So 7.38 divided by 160. And I get a number. 0.046, whatever. And that's a lot of decimal places. We're going to be rounding to whole numbers anyway, so it really doesn't matter to go for sig figs or any of that. And this is going to be moles of the anhydrate, which if you'd like to be specific, you can say just the copper 2 sulfate. Then it says calculate the number of moles of water in the hydrate. So we had grams of water was 4. And the GFM of water, which you might already remember, it's 1, but there are 2 of them. And 16, and there's one of them. So 18 grams per mole. So 4 divided by 18. Repeating, moles of water. Now it says calculate the mole ratio between anhydrate and water. Show all work. So we have to look back at our questions before. So we had 0.046125 moles of the anhydrate, and then we had this moles of water. So to figure out the mole ratio, we divide each by whoever is smallest. So in this case, it's 0.046125. 0.046125. So this is going to be a 1, obviously. And when I divide this, I get 4.817, whatever. Now, the rule with rounding, if you are 0.5, if this is 4.5, I would double both of them. If you are below 0.5, you would keep it or round it down. If we are above 0.5, which we are, we'll round it up. So 4.8 would round to a 5. So the CuSO4 has a coefficient here of 1, a ratio of 1, and we would have 5 H2Os. Then it says calculate the gram formula mass of this, show will work. So this is my experimental. You might get something different with your lab data, and that's okay. You will use this. I don't care if you get the right one or not. I want you to just go from there and use your data to guide your calculations. So I'm not going to calculate GFM for you, but in my experiment, we have this. So, just go ahead. Remember, you don't need that. Remember that you're going to add this plus this, and your units, remember, grams per mole. There's actually nothing to calculate here. But you can see that my calculations gave me the exact same formula as the true formula. And that might be the case for you too. So, you would, if you did get the same one, you could say see question number 5. If you had something different, you would calculate. Now, percent error. Table T has the formula. That's actual value minus measured value over actual value times 100. Even if you have the same thing as me where we have the same value, show me that you're going to get 0% error. Show me the work, even if it's a 0% error. Then it says calculate the experimental percentage of water based on the present in the hydrate based on the collected from the data table, show all work. So remember, percent composition is mass of part over mass of whole times 100. So we would need to go to the data table. So going back here, percent water would be mass of water over mass of the whole thing times 100. So 4 over 11.38. 4 over 11.38 times 100. So then I would do that, and then whatever I get times, percent sign. Now this is from the data table. That is my experimental or my measured value. An actual percent percent water would be using GFM. So that would be 5H2O over CuSO4.5H2O times 100. And again, you would be using GFM. So this is going to be 5 times 18, and this is going to be that whole thing, times 100, and you get blah, blah, blah percent. And so I'm not going to give you that answer. You can do that. So this is the true value of the percent water. This is what you got in the lab. Question 11 says calculate your percent error between the two. So your actual value is your answer for number 10. Your measured value is your answer from number 9. And you're going to do, percent error. And if you get a negative, you need to just make it positive, something. And I don't really care about sig figs for that. All right, if this is not enough help for you, please reach out. Please let me know. Otherwise, good luck. Take care.